Alright, what's up, y'all? Today we're going to be talking about triangles. Okay, now we're going to be talking about two parts of triangles: right triangle trig and similar triangles. Okay, so let's start with the right triangle trig. Okay, trig right here. It's very simple. It's so, ka, toa, right? Now, what this is, alright, it's sine, cosine, and tangent. And this is very simple, alright? Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent, just like so, ka, toa. Very simple. Alright, so let's do a little practice problem here. We have an angle here, 34 degrees. And this side right here is 25 feet, okay? And we're trying to find x, okay? Now we're trying to find x, and it's opposite over hypotenuse. Now we have the hypotenuse, so then we would use sine. Sine 34, okay, equals x over 25. So now, to get x by itself, we want this to be x equals, right? So we would multiply each side by 25, gives us 25 sine 34 equals x. Plug that into a calculator, gives you 14. So that is trig. Now we're going to be talking about similar triangles. Very fun. So similar triangles is triangles with corresponding sides. No, actually, I take that back. It's proportionate sides and corresponding angles. So let me draw this out so it's a little easier to understand. Okay. So this would be a similar triangle. Let's say this is 2. Let's say this is 3 and 4. Okay. Now here's the angles. All right. For this to be a similar triangle, this would have to be proportionate. So let's just multiply each side by 2. Gives us 4, 6, 8. Same angles. Okay? Needs to be same angles for it to be similar. So let's do a little practice problem here. Alright, so this triangle right here is a 5, 4, 3 triangle with sides W, U, and V. Okay, so this triangle right here is we got 12 on this side, and it's x, y, z. Okay, so it's x, y, z. Now obviously the angles are the same, but we're trying to find what this side right here, xz and zy is. Okay, now to do this we need to set up a little proportion here. So it's 3 over 12 because UV is the corresponding side to XY. Okay, so now this gives us the scale factor of 1 over 4. So once we have this proportion, basically, very simple. Now all you have to do is divide 4 by 1 over 4 and 5 by 1 over 4 to find this side. Now if you do that, if you plug in 5 divided by 1 over 4 in a calculator, this will give you 20. Okay, and if you plug 4 divided by 1 over 4 in a calculator, this will give you 16. So that is how you find similar triangles.
Okay, so in addition to what we already talked about, I just wanted to go over some similarity postulates and theorems. So the first one is the angle-angle similarity postulate, meaning that if two angles of a triangle are congruent to two angles of another triangle, then the triangles are similar. Second one is the side-side-side similarity theorem. And so what this means is if all three sides of a triangle are proportionate to the other, or proportionate to the corresponding sides of a triangle, then the triangles are similar. Third one is the side-angle-side similarity theorem. What this is saying is that if an angle of one triangle is congruent to an angle of the second triangle, and the lengths of the sides including these angles are proportional, then the triangles are similar.